Yes, started.
Good afternoon, everyone, and welcome to the second lecture of the Chemical Engineering lecture series. My name is Gautam Jagdishan, a faculty with the School of Chemical and Biotechnology. So, as you probably would have, listened to the first lecture or the inaugural lecture of this Chemical Engineering lecture series, this lecture series is essentially intended to provide all the students with some additional co-curricular exposure from various speakers from the industry, academia, and so on. Due to the pandemic situation, we are essentially having this entire thing in an online mode. Well, there are certain disadvantages to it. There are also some very great advantages, such that we can have people of eminence actually coming and talking to our students from various parts of the globe using this technology. So in that endeavor, we have arranged this lecture series so that everybody can actually come and attend and gain the knowledge from some of their seniors, people who have been there in the industry, so on and so forth. So in that sense, today we actually have an alumni from Sastra, Mr. D. Saravanan, who is also happens to be a friend of our own faculty member, Professor M. Saravanan. So I would like to take this opportunity uh, to pass the mic on to Dr. Alagation, who will introduce our speaker. Just for the sake of for having a clear presentation and a live webinar here, I kindly request all the participants to mute their mics and also switch off their videos for better clarity and better transition. Any questions that you may have during the presentation by our speaker will be taken up at the end of the session, either via the you can post your questions in the chat, or you can separately email them or ask them after the presentation is over. So with that basic framework, I will now like to introduce to have Dr. Alagason actually introduce our speaker. Dr. Alagason.
Yeah, thank you. Good afternoon to all the students of chemical engineering and to my faculty colleagues. It gives me an immense pleasure in welcoming you all to this chemical engineering lecture series. This knowledge forum series was inaugurated by Mr. Arulmani, speaker and alumnus of our chemical engineering, along with our Dean SCBT on 5th September 2020. In that first session, Mr. Alumani has set the strong foundation to this chemical engineering lecture series with his talk on project management. Today, we are pleased to have another speaker from industry, Engineer Saravanan D. I am proud saying that he is also an alumnus of our chemical engineering. Of course, there were 3 Saravanans in that batch. Among those, 2 of them here. One is our faculty, Mr. M. Saravanan. Other one is in the dais today. Probably third one is R. Saravanan, right, may join later in this session. So with this, thanks to Engineer Saravanan D for being with us today. Our chemical engineering department has been running with the ISCHE student chapter successfully so far, which provides the platform to our students for performing the co-curricular activities, in which students are able to uplift their personal skills by conducting seminar, conference, the quiz competitions, and so on. This semester, it is unfortunate that the students are missing out of such activities and taking part only in the online classes due to pandemic situation. In order to overcome the lagging behind on this such co-curricular exposure, so this lecture has been arranged twice in a month. I hope this forum will definitely bring out a lot of industrial people to deliver the professional ethics and management to our students. In this concern, students also can feel very confident towards the professional life they are going to face. With this, I welcome you all again for the today's session. Thank you, one and all.
Okay, so we can start. Yeah. So can I like
Yes, sir.
present my screen?
Yes, sir. You can actually start, sir. Yes, sir.
Yeah. Let me just like present my screen.
Sir, if you can hold on just a moment, Saravanan, sir, before you present. Now I would actually request Dr. Rangabasham to give us a brief intro about our speaker, Mr. Saravanan, before he can start. Dr. Rangabasham?
Yeah, good afternoon. Our speaker, today's speaker, Mr. Saravanan, completed his bachelor's in chemical engineering from Sastra deemed university, master's in the Department of Energy Engineering from National Institute of Technology, Tiruchirappalli. He had over 18 years of extensive experience in energy policy and regulation, climate change strategy, energy standards and labeling, demand-side management, carbon management, sustainability strategy and reporting, and on-site, off-site training and transition management. He has worked on analysis of economic and financial implications of clean energy policies on business and development of financial assessment models to evaluate energy efficiency projects for both government agencies and private sectors to improve engagement in green growth strategies. He is currently working with the Emirates National Oil Company, ENOC, a wholly owned entity of the government of Dubai, as the senior sustainability specialist in shaping ENOC's approach to clean energy and sustainability issues. Thank you. Gautam sir.
Yeah, thank you, Dr. Rangabasham, for the nice introduction. Now, I would like our speaker, Saravanan sir, to actually present his screen and provide his lecture to the students on energy issues facing our daily lives. Again, I would ask all the participants to mute their microphones and their videos, and we will take questions after our guest actually completes his presentation. Thank you very much. Mr. Saravanan, please, you can start, sir.
Wonderful. I think like you are able to hear me loud and clear, though, right?
Yes, sir,
I
we
just
are.
want to check that. Okay, perfect. So I hope like you are able to see my screen as well right now. Are you able to see my screen? The presentation screen.
No, sir. We are not able to see the screen as yet, sir. Yes, sir. Now it is showing up, sir. Yes, sir. Yes, sir. We are able to see the screen now.
Okay. Okay, perfect. Okay, wonderful. Thank you. So first of all, thank you so much for giving this opportunity. Like, I'm really excited. Means to like come back to the school where you have studied and share my thoughts. So it looks like as if yesterday, but indeed is like a couple of decades. Yeah, a couple of decades, 20 years before when I was studying the chemical engineering in Sastra. During that time, it was called as ChEL02 as well. So it was as of like looks like okay, it's yesterday. It's 20 years now, and I'm so excited that okay, I'm going to have a talk with young budding chemical engineers who had the similar kind of or have the same kind of aspiration when I had 20 years before. In fact, like okay, to be very frank, means during the early during the early 2000, okay, everybody was actually talking about computer science, people who like to go into IT industry and things like that. But personally, like okay, I took a decision. My dad was recommending, IT engineering or computer science, but I took chemical engineering, and here I'm now, like in front of you, like so talking about what we as chemical engineers can do to make the world a little bit better. So this is what the topic is like. what are the challenges the world is actually facing, especially like, okay, how like we as chemical engineers, like we had played a great role in shaping up this world in terms of like, okay, our contribution towards process engineering, especially in petrochemicals. But right now, as we speak, the world is actually like facing a transition where the world is actually moving towards without oil. And what is our role as chemical engineers? So I'm going to talk about like the next 60 minutes on that. So in fact, it is not about like a life without oil. In fact, it's actually like going beyond oil. So even though like there will not be like any more oil refineries or like any more major oil and gas companies, like I'm not saying, okay, in a decade or so, maybe like after 2 or 3 decades, okay, probably the world will actually see that. But still, we as chemical engineers, we have a great role to play. So again, like, thank you so much for the professors here. Especially like I remember Professor Punnusamy, like he was actually one of the lecturer, like, okay, he took, I attended his class. I'm glad that, okay, he's actually here. So thank you again for this opportunity. So just to like, so some of, so the professor already given me an introduction, but this is me. So I have done my chemical engineering and I've done my master's in energy engineering, having around 18 years of experience in the field of energy. I've done some crazy things in my career. I worked for a bank. I worked in consulting. Now working for a process engineering, like oil and gas company in Dubai, primarily looking into sustainability and strategy for ENOC. Okay, what as an oil and gas company have to do in coming decades because of the challenges we are right now facing. I'm so also glad that means we are able to do this, although like COVID has actually created as a challenge. Okay, but I believe like without COVID, probably like this would not be happening. Actually, this is one of the good things which is happening now. Yeah. Like I get to meet you like at least virtually, but if COVID is not there, probably like okay, we will always be thinking of in-person meeting. So here is a short agenda of what we are going to like see. So I'm not going to go into like too much technical, although like I'm going to like touch some technical topics as well, like concepts like life cycle assessment or pinch technology or process intensification, which we do like do on a day-to-day basis and in industry for designing or revisiting or retrofitting our processes. But I'm just going to give you a context, like okay, why this is actually an important topic. Right now, especially we as chemical engineers who are going to like play a major role in oil and gas and petrochemical industries. So I'm going to give a context, like okay, how this oil and gas sector is actually witnessing a transformation right now, and how oil has actually played a greater role in our life before, and how our oil dependency is actually gradually going to change. What are the solutions we are actually looking at right now, either in the form of electric vehicles or green energy, and what kind of regulations are actually coming up in terms of the limitations to on global GHG emissions, carbon emissions, and how they're actually doing it through pricing carbon. I'm just going to give you a snapshot on okay, how they're actually like doing it globally, and what are the other solutions available apart from like these regulations. One of the key solutions is like energy efficiency, like improving energy efficiency in process industry. So what are the tools? So such tools like we use like LC and pinch technology to encourage or like to implement energy efficiency projects within our industry. So I'm going to like touch a couple of tools. Then with that, I will end up. So probably like okay, it might take like maybe another 45 minutes or so. But I'm going to keep it simple, and let's do it. Okay, so to start with, so it is always like okay, it has been okay since the start of the industrialization. Means you can actually like see life is always like with oil, means oil has actually played an important role in our life. Okay, means without oil, means we would not have been actually like seeing what we are actually like witnessing now. But before this oil industry, okay, it is not, it is always like not life with oil. Means before that, okay, people are using animal power, means we are having coal powered train engines. We were actually like powering even the Titanic, the famous ship, okay, with coal power. So, but the discovery of oil actually completely like changed. In fact, it was actually, or the oil was actually discovered somewhere during 1859 in Pennsylvania, okay, in 1859. And if you see like what has happened in Middle East, it was somewhere during 1908. It was actually first discovered in, I think it's like in, in Iran. Yeah, it was during 1908. If you see, okay, what's happening like in Dubai, in Dubai, they struck the oil like somewhere during 1958. And right now, like UAE is actually like one of the 6th largest proven reserves, having oil reserves in the world. And currently, like UAE as a country means we are actually producing almost like 4 million barrels per day. It's quite significant. For example, Saudi is actually like producing somewhere close to like 10 to 11 million barrels per day. Russia doing around like in the range of 10. US actually has overtaken both Saudi and Russia, and they are doing actually 12 to, and possibly they will touch 14 or 15 million barrels per day. So he is actually like one of significant oil producers. But this oil has actually completely like transformed a country like UAE, which was, like it's a desert. It's completely, we just see 2 seasons, either like very hot summer or cold winter. So the oil during 1964, you can see the country was like this, but right now means it has completely like transformed into something amazing. One of the famous roads within Dubai is called the Sheikh Zayed Road. Okay, during 1990, you just see a couple of buildings, but in 2008, okay, in a couple of decades, that's actually like what Dubai has done is like transformational. Yeah, within a couple of decades, they transformed Dubai from something like this to skyline full of skyscrapers. So this is like amazing, and one of the reason is oil, or one of the major reason is actually like oil. So what oil has actually done to us? So if you see, by the beginning of 20th century, the oil is like just like 4%, 4% of the world's energy consumption. In 2019, if you see, means what is the oil's contribution to world's energy demand? It is as good as like 33%. Almost 1/3 of the energy demand comes from oil. And then of that, if you see transportation sector, almost 95% of the oil which we are actually like using for transportation, 95% is actually comes from oil. So this is like an amazing transformation. If you see a nice chart, means you will find that almost 1/3 is from oil, and the remaining is from natural gas and coal, and then comes nuclear, hydro, and renewables. So this has been like a great growth. But if you see like an overall as a trend, okay, a percentage share of oil, means you will see this like a percentage share of oil. So it is like close to like 40%, and right now what we are actually like seeing in the range of 33%. So you can actually see what the trend means, what the trend of this oil and gas industry means, where it is actually going. So just keep this in mind. This is an actually important chart which shows how the world is actually looking at fossil fuel reserves. Yeah. So with that, so where oil is being used means anything you touch, anything you touch in this world, it has its origins in oil. Yeah. anything you touch. You talk about medicines, you talk about plastics, you talk about transportation, you talk about food production, marine transportation, anything is being like powered by oil, nothing but oil. So it's like a very major industry. At one point in time, people were like very proud that, yeah, I work for an oil and gas. I work for, say, for example, in India, in Indian Oil or ONGC, or like I work for BP, Shell, Chevron. Okay, right now, like in Dubai, okay, I'm probably saying I work for the Emirates National Oil Company of Dubai, the government company of Dubai. So oil is actually like everything. So why oil is very important? Because it has some amazing qualities. Yeah. For example, if you just ask, yeah, we are actually using oil to power our cars. If you just ask, okay, how many men does it take to push a car? So it actually like says that a tank of petrol is actually equivalent to almost like 8,000 human hours of work. Okay, in a year we have 8,000 hours. Okay, 8,000 hours approximately in a year. So it's almost equivalent to like a 1 person work. Every tank of petrol is equivalent to like a 1 person work. So which is like amazing, because a tank is equivalent to 1 person's work for the whole year. So that's the reason 95% of the transport is fueled by oil, and that is actually because the gasoline or the diesel or petrol, whatever you call, is it has become such a successful energy source for the humanity because it's convenient. It has a great energy density. Like, okay, what do you mean by energy density? Like how much energy it actually like stores per kg or per volume. And although like, okay, yes, it's relatively safe. So it has actually done great things for humanity. And what is actually done for the humanity? So if you see the trend in world's population, yeah, world's population, how many number of people living in this world, you will actually like find that till 1800, yeah, 1800, the world's population is like somewhere around 1 billion people, around 1 billion people who are living. And by 1900, it went to 2 billion. And right now, like, okay, we are in the range of 7.4 billion to be precise, okay, right now. So it took actually like several hundred years to reach 1 billion, and another 100 years to reach 2 billion. But within like 70, 80 years, it has actually like grown by more than like 3 times, yeah, 3 to 4 times, almost like we are touching 8 billion right now. And what they're actually predicting is like, okay, we will probably like go to like close to 10.5 billion, or even like as good as like optimistic projections says that we'll probably like touch 14 billion by 2100. So if you ask a question, what has happened? What is a miracle which has happened? Like, okay, we were actually growing at a rate of 100 million per year for every 100 years. And we are now like talking about 2 to like 3 times growth. So what has actually like driven this growth? So absolutely, the answer could be like again, it's because of the oil. Okay, oil is nothing but like equals food. So oil, 95% of food products actually like requires the use of oil. And anything like okay, you want, okay, the yield which we get per acre or per hectare of land has gone substantially because means we got this cheap energy. It's fossil fuel energy, oil. And if you just calculate, yeah, it's almost like 400 gallons of oil is equivalent to like to feed 1% in US. So whatever the food we're actually consuming comes from oil, and that has actually like fueled this population explosion. Okay, which from 2 billion to right now we are saying like 7.4 billion. So how we can actually like see this correlation? If you put a chart between the world population and the oil growth, means it is not very surprising like to see a very good correlation. So we are like less than 1 billion people, but if you put it like, along with the oil production, you'll see like both are like very highly correlated. So oil has driven this human population, and which is indeed good for us. It has actually helped us in a lot. We have achieved very high human development index. People make more money. People are like more healthy. Okay, we are able to like raise more children. So everything is actually like good. But if you see like the number of new oil discoveries, okay, the new reserves, okay, whether we'll be able to sustain this oil production, okay, is that actually going up or going down? So if you see the statistics, okay, since 1947, you can see the number of new oil, okay, where we can actually go and tap conventional like oil reserves. Okay, means people are actually like going have to like go offshore. Okay, much more deeper. Okay, deep sea oil drilling. So we are actually pushing ourselves to find more and more oil reserves. So, but if you see the number of oil reserves which are being like discovered, it's actually like falling down. Okay, it's actually like falling down. We had a peak somewhere during 1962, and right now it's actually like falling down. So what it actually proves, so oil is actually like an finite resource. Yeah, it's like everybody knows. Okay, it's nothing. It's not a surprise. So everybody came up with a concept, especially it came like somewhere during like 1956 when oil was actually one of the major energy driver for the world. They came up with the concept, oh, so there is going to be peak oil because oil is like finite. Okay, it's a finite resource. It's not renewable. Okay, it's a fossil fuel. So it is going to like decline, means as we like utilize more and more oil. So they actually like said that during from 1975, okay, the oil production will actually come down because there is no oil reserve. Okay, equivalent oil reserves we are actually like able to come up. So that's the famous peak oil theory, and it was from a person called King Hubert, and he said that okay, from 1970 onwards we will see. So that's a great theory, and everybody was acknowledging it, and that also like led to the price rise in oil. You know, like okay, it was less than $1, and during like when the OPEC, the oil exporting countries, they formed the association, and then they raised the price from $1 to $4, and they created like a lot of things in the world. And it was actually true. It was actually true. But if you actually like see the statistics now, how much is production? So it is actually following this peak oil theory. But since 2015, like something came up. Okay, means we found a new way to produce oil. People like okay started finding new ways to produce oil through shale drilling and fracking. And right now, means you see the graph. Okay, yes, the oil production is actually like declining, but right now it is again started going up. We are again close to 1970 levels. Okay, so there is no more like okay peak oil theory, means our technology will actually grow up, so we'll be able to find more and more new ways of extracting fossil fuel reserves, new ways of like going offshore, deeper sea drilling. So it is no more the peak oil theory. So why we are actually like then talking about life beyond oil? Yeah, so we know that okay, yes, we will have a technology, we will find new reserves. Okay, then why we are actually like talking about life beyond oil? Because oil is anyhow there. Yeah, you see like oil is anyhow there. It is not, the oil production is not declining. So why we are actually talking about life beyond oil? So that's why this concept comes, because oil is like a finite resource. Okay, so the population is really growing. Okay, in 1989 we were at 5.2 billion, and today like we are close to like 7.4 billion, and it will be close to like 10.9 billion by 2100. So the world simply does not have enough resources to support this exploding population growth. Means what they actually like say is by 2030, means you would require like okay, 2 planets of Earth to support such population growth. So we are slowly understanding that okay, whatever the resources which we have, not necessarily oil, means if you take any other resource, water, coal, even iron ore, copper, whatever it is, okay, we simply don't have enough resources in the earth, and we would, to sustain that population, okay, to have a same level of life or same level of human development index, we would require 2 planets by 2030. Okay, so the concept of sustainability came into picture, and also like means generally like okay, during industrialization, they just had this mindset that okay, whatever the industrial waste you generate, okay, either the waste we generate which can be discharged into the land or the water bodies, and more importantly the atmosphere, okay, people generally think that okay, yes, it is like a vast space, we can actually pump whatever we can. But this is a nice picture normally like okay, I use. So this actually like shows the Earth rising, a picture taken from Apollo 8. So we can actually like see okay, the space okay is not complete. It's not like okay, we have an infinite area and we can keep on pumping. It is hardly like just 100-kilometer thick. It's like a very thin, fragile atmosphere which we have. So what is actually like creating is the problem which we are seeing is like since more and more fossil fuels are being used, like oil, okay, and including coal, we during industrialization means we are actually like pumping like more than 110 million tons of GHG emissions every 24 hours. And if you see like what is our current global carbon footprint, we are like in the range of 36 gigatons of CO2 per year, which is like yeah, that's a great number. So what it is for us, but if you see the concentration of CO2 ppm in the Earth's history, okay, if you go back to past 800,000 years, the concentration of CO2 ppm like is in the range of 280 ppm, yeah, less than 300 ppm. But right now, as we speak, okay, this chart actually shows 2008 observed. But right now, as we speak, if you go and actually check, you just Google it and you go and check, so what is the CO2 ppm right now? It is actually like close to around 415, okay, 415 ppm. So the Earth has never ever witnessed such a very high concentration of CO2. It's not like for 100 years, 200 years. It's for past 1,000,000 years, the Earth has never ever witnessed such a very high CO2 concentration. In fact, it's actually a surprise for me. Like when I started working on the concept of sustainability, when I worked for Ernst & Young, and subsequently for HSBC, when I set up the Climate Change Center of Excellence for HSBC, and I was there in London to set up a carbon trading desk for HSBC. We were actually like in the range of 380 ppm, yeah, like just like I'm talking 10 years before. And within a decade, we are like close to 415 ppm. We are actually like growing at the rate of like 1 to 1.5 ppm per year. So what's a great deal about it? Yeah, the CO2 is actually like going up. It's hardly like, okay, it's in ppm level. So what's a great deal about it? And you know that okay, most of it actually coming from the fossil fuel. So the main problem is actually like, okay, it is creating the issue of global warming. Means everybody knows this. Yes, the average temperature of the Earth is actually rising. You see a lot of articles about it. The greenhouse gas effect. So you know this. So it's a simple concept. So more CO2 you pump into the atmosphere, it traps more and more heat, and it is equivalent to like 400,000 atomic bombs exploded per day. So yeah, so Earth temperature is increasing. So the question is like, okay, oh, so what? So So we see the average earth temperature is actually going up since 1980 till 2000s. It has actually gone by like 0.74. Okay, I think if I remember correctly, 0.74 or and above the mean average of 20th century. So the problem is like the temperature is actually going up. Okay, and this is the typical mean of summer temperature. Okay, the summer temperature. And this actually shows between 1915 and 1980, what is the average, or how is the standard deviation from mean of these summer temperature. But as you see, like as we move closer towards 1980s and 1990s, you can see it is actually shifting to the right. And if you see now, like 2005 to 2015, it is actually has shifted even more to the right. So what it means, so the summer is getting hotter and hotter. We are seeing extremely hot temperature. So if you take a statistics, okay, since the year 2001, okay, how many hot years or hottest years on record has happened? You will see that 14 or the 15 hottest years since 2011 actually happened very recently. Okay, very recently. So most of the hottest years, 2016 is the hottest year on record, followed by 2019, followed by 2015, followed by 2017. So we know that, okay, something, whatever we have done during 1960s has contributed. And we know that, okay, yes, it is carbon dioxide. And the CO2 ppm has actually gone up from 280 to like 415 right now. So again, where this heat is actually going. So most of the heat is actually like getting trapped in the oceans. Okay, whatever the extra warming we are actually like creating, it is getting trapped in the oceans. And if you see, yeah, for example, like in 2015, the North Pole has actually like reached more than, the temperature was like 10 degrees higher than the freezing point. So what it actually means is right now, like as we speak, the polar ice caps are actually melting. And whatever the glaciers we saw like during 1940s, right? Okay, it turned into a lake. Or if we had a lake, then okay, it turned into it's slowly turning out into a desert because the average temperature has gone up. There is more evaporation ratio, and we have like multiple impacts. Yeah, we have like frequent weather disasters, but means all these things are like okay. Oh yeah, like okay, we are finding more and more heavy rainfall. Yeah, so you saw that what has happened in Mumbai, the heavy rains, recent heavy rains which we saw. The ones right now as we speak, we have extreme wildfires happening in California. So it's all great, but if you convert those into like numbers, yeah, numbers means like in terms of money, then it comes completely like gives us a different perspective. Okay, yeah, the temperature has gone up. The ice is actually melting. We have disasters, like weather-related disasters. But if you put that in terms of like financial impact, then it actually like shows a different picture. So you can actually see because of this climate change or global warming, you can see almost like most of the countries will see a negative trend in economic growth. Okay, including India. There are a couple of countries like okay, they will actually like see a positive economic growth because they're already cold. So and if they're actually getting warmer, their economic productivity or their agriculture yield will actually go up. So it's still good for them. It's like countries like Russia and Canada, but except for countries like Russia and Canada, all other countries will see a negative economic growth. And you can see, especially the countries, underdeveloped countries or developing countries, they will have the highest impact. Yeah? Countries like India, countries in Africa, Brazil, they will see a greatest impact in terms of GDP, whereas US or Europe, okay, Europe actually like slightly see positive because like they are already cold. Europe like will have a slight impact. So that's actually a great economic impact. And if you see the weather-related losses, okay, since 1980, like till now, and if you see the statistics, you can see the weather-related losses actually like going up more and more. We see climate-related disasters, and this is a famous chart from Munich Re, the insurance company, and you can see they are means the insurance companies are more concerned because they have to shell out more and more on insurance claims. So they track it very closely, and based on that, they revisit their premium as well. And they are like seeing that the more and more closer, the last decade, they have to like shell out more and more money because the disasters are happening. So I thought that, okay, I can actually ask some questions, but I believe we will just continue. Yeah, is it like okay, like whatever? Am I like my audio is clear? Are you able to follow what I'm saying?
Yeah, yes, we are. And you are welcome to ask questions to the students. I'm sure they will love to answer.
Okay. I just thought that, okay, it will be like a little bit interactive. So might be, yeah, here is a question. Okay, could be like okay, simple and trivial, but I just want to take a pause and see whether how if you ask a question, how you will respond. So if I ask this question, the primary source of energy in Earth's climate system is what? So maybe like you can just tap, yeah, in the chat box. Yep, yeah. So I can see Nathan S typing sun, yeah. So sun is the answer. Okay, here is our question. So which of the following gas does not trap heat? So we talked about greenhouse gases. So which of the following gas does not? Okay. Okay, everybody's saying B, nitrogen. Okay, very good. Okay, yeah. So in fact, water vapor is actually one of an important greenhouse gas, but we are not actually controlling water vapor. It's part of the natural cycle. Okay, whatever means the gases which get generated because of human activity is carbon dioxide and methane. So burning fossil fuel is the major source of human produced carbon dioxide. What is the second leading source? Okay, the carbon dioxide majority is coming from fossil fuel combustion. So what is the second major leading source? Okay, I can see Lakshmi Prasanna saying deforestation. Okay, some Rajshri, Akila, forest fire. Okay, most of them saying D. Some of them saying deforestation. Okay, Gautam saying volcanic. Okay, interesting. But the answer is deforestation. Yeah, the answer is the correct answer is deforestation. Okay, it is not about forest fire or volcanic activity, because as we speak, okay, right now, whatever like okay, happening in Brazil, we are just like clearing of Brazilian Amazon forest at the greatest rate in the human history. So just to what, thank you for that response. Just to what, continue. So how do we move forward? So we know, okay, this is the problem. Yeah. So how do we move forward as an oil and gas sector? So the concept is like we understood that like, the concept is no more about peak oil. So if you track the oil consumption of OECD countries, okay, OECD countries, if you see their oil consumption from 1994, yeah, it peaked somewhere during 2005, and then it started falling down. So what we are actually seeing, why it is actually like happening. So it's not about like, okay, we will not be able to go and find oil, but it is a concept called peak oil demand. Okay, was it actually like what's happening within the transportation sector, which is actually responsible for the fall in oil demand? So if you see the latest projections from IEA, the World Energy Outlook, okay, it shows how much the quantum of energy we are actually like consuming per year. So you can actually see the overall energy demand of the world almost stays stable, but the energy consumption, okay, from various sources like from coal, oil, natural gas stays more or less flat, but the energy consumption or energy contribution from coal and oil, it's actually like falling down. And you can actually like see a dip what is happening in 2020, and that's actually because of the current challenging situation we are facing because of COVID. Because like, okay, we are stuck inside the home and you're not actually like traveling, and okay, the economic activities actually has gone down. Okay, so because of that we see a dip in 2020, but overall over the next coming decades we see that the contribution from oil, okay, and especially the fossil fuel sector is actually like go down. It's go down. So it's no more the concept of peak oil. It's no more that we will not be able to like find oil, new oil reserves, okay, economically viable oil reserves, because people actually like will move away from oil, okay. So there is a famous quote from the ex-Saudi oil minister. So what he said is like, okay, the Stone Age didn't end for the lack of stone. Okay, means we moved from Stone Age to consequent ages. We moved from stone to iron to brass and copper. We moved on. That actually happened not because of lack of stone. Similarly, like the oil age will end long before the world runs out of oil. Okay, it's not that yeah, by 2050, 2060, the world will run out of oil. Then we will actually find another alternative solution, which could be, we will see the solutions right now, okay, but so it's not the concept of peak oil, okay. It's not because of non-availability of oil means the oil production will come down. It's actually because means we are actually waking up to the scenario, okay. We see means what are the challenges we are facing. The concepts like sustainability is actually like, okay, pushing the world to peak oil demand rather than like a peak oil. And that is actually like creating huge pressure on like fossil fuel companies, especially like oil and gas companies. Okay, so what it actually like says is because of these limitations or the movement away from fossil fuel industry, we can actually like see that most of the reserves which we own as an oil and gas company is probably like, okay, will not be extracted. Means we have found those new reserves, but we will not be able to like actually use it, and that will create this concept called unburnable fossil fuels. Okay, you will have those reserves. Okay, those are like viable economic reserves, but you will not be able to like use it because the world has actually moved away from it. So that's why, like, okay, if you like watch the balance sheets of Shell, BP, like Chevron, okay, their stock price is actually like linked to the assets which they own, and every year on year, they are actually like downgrading the value of the assets they own because they know that, okay, by 2040, 2050, they will not be able to extract those oil, and they will not be able to extract means they will not be able to extract and sell. And because of that, it will not get reflected in the share price of those companies. So it will create this unburnable fossil fuels. Okay, so this is a huge issue, like for us, like as an oil and gas sector, or a company like from fossil fuel. So how this can happen? What are the things like we can actually like do? So these are like just like a thought. So if you see the pictures of 1900s, okay, how the city would look like in 1960, 1980. So these are like when you asked the artist to draw pictures, how your future city will look like, they drew pictures something like this. And during 1900s, like okay, when the artists do the picture something like this, like people were like laughing, okay, how can this be? Okay, roads filled with skyscrapers, or like okay, having flights going up and down. So people were like, okay, in fact, thinking, okay, these artists, some of these artists are like really crazy. And we do think if you see posters now, okay, for example, if you talk about like this movie posters like Interstellar or iRobot, we think that, okay, these are like crazy ideas, okay, because like we have this inability to vision the future, okay, what we actually want. We are not able to like visualize how the technology will improve, or how soon the world will actually move on from the fossil fuel. So that's why this concept of sustainable development, which will like able to ensure or transform the way the world we live in much sooner than we think. Okay, so the concept of sustainable development, just to quickly like show, so it's around we will achieve economic development. Okay, we have to achieve economic development, but not at the expense of environmental development. Okay, our environmental impact. At the same time, you will have also like a social development. So it's a triple bottom line approach. You know this like in and out. You'll be studying it in your classes. So, but it is going to transform the world we think. Okay. Oh, so here is a couple of questions again coming in. So which of the following would have the biggest impact on reducing carbon emissions? Any thoughts? Okay, Nathan again saying D. Option C, option B. So most of us saying taking all the fossil fuel burning vehicles off the road. Okay. So most of us saying B and C. Some of us saying D. Okay. Okay. So, but the answer is actually energy efficiency. Okay. So this is like kind of a primer question. So I will show you in subsequent slides why energy efficiency is actually important. It's going to play an important role in transforming the world. So how we will do it? Okay, so we talked about, okay, great sustainable development, talking about triple bottom line approach, but how we are going to do this? So now for the good news. So yeah, so one of the option, okay, let's actually like have to like go back to 1900s. Okay, you know that like oil and gas or oil is primarily like used in transportation sector. And in fact, it is not always the case. During 1900s, in fact, if you see the history, the electric vehicles, they actually peaked in 1912s. There were like more than 30,000 electric vehicles, okay, in US and 4,000 electric vehicles in Europe. So it was like a very popular car. But during 1912, gasoline started to take over. Okay, that's actually because they are the gasoline powered car, they are able to like drive faster, and they are actually, more importantly, they have addressed the issue of range. Okay, with 1 tank liter of petrol, they are able to cover 200 miles, 300 miles. They're able to like address the issue of range. And also like Ford famously came up with this concept of mass production of cars. And finally, like to start the gasoline cars, they came up with this automatic electric starter. Okay, and that actually sealed the popularity of electric vehicles during 1912. But we had to look back, and we had to go back to electric vehicles, and powered by green energy, yeah, powered by green energy. So we have electric vehicles. The electricity currently is coming again from fossil fuel, but you power it by green energy. So then, okay, it'll be like completely clean green. You will be able to avoid the CO2 emissions. But can it be done? Because is it feasible? Because like the moment I say, okay, let's actually like clean energy or green energy, means we think that, okay, it is expensive, it's economically not feasible, and second, it is like unreliable, yeah, because renewable energy sources like sun or wind, it depends on the fluctuations in how we get solar radiation or the wind flow. So we think that, okay, yes, like it's unreliable. So, but if you see, the renewables are actually catching up. So we will try to answer these questions. Okay, I'll try to answer these questions. Just like bear with me like a couple of minutes. But renewables are actually catching up. So if you see the quantum of power generation added year on year, okay, in terms of gigawatt, you can actually see since 2010 it went to a peak for fossil fuel, almost like 141 gigawatts, and it's actually like falling down, expected to fall down. Whereas the clean energy, okay, it's primarily like solar, wind, nuclear, and small hydro. It is actually like going up. It's actually like going up year on year. And it's not only about they're going up year on year, but here is an interesting chart. So this is actually the chart which comes from IEA, International Energy Agency. The IEA actually like produces an interesting report year on year. They call it as like World Energy Outlook. Okay, World Energy Outlook. And every year they actually like project how different types of energy sources will actually grow year on year. So they actually like predict every year what will be the growth in renewable energy by 2015, 2025, and 2035. And this chart actually shows the comparison since the World Energy Outlook started like in 2006, right now like till 2018. So they have actually like predicted that, okay, these renewable energy, like including like solar PV and wind, they will grow, but they will grow at a rate of like maybe like a CAGR of like 2 to 3%. Yeah, so this is their prediction. So all these lines actually like shows the prediction. But again and again, the renewable energy has actually like beaten the forecast. They have actually achieved exponential growth. And this actually like shows the PV growth, solar PV growth. So they are actually growing at an exponential rate. But if you see the projections from IEA, one of the world-renowned, the only renowned institute, okay, to like look back for our energy data, they are not actually able to predict the energy growth properly. So why this is happening? Okay, what is actually going wrong? Okay, what is actually like going wrong? Is there any precedent for such rapid adoption of new technology? Means, is it like something wrong in our prediction methodology? What is actually like happening? If you see like other examples, any example, okay, either radio, TV, internet, mobile, you will find that they all follow this. This is a famous chart, okay, the S curve. They call it as the S curve. You will find that they all follow this exponential growth. So it's for example, AT&T. Yeah, they asked McKinsey how many mobiles, like if you will, McKinsey, the famous consulting company, how many mobiles we will sell by the year 2000. Okay, they asked in 1980s because they want to install the towers, that's the mobile towers. So they want to gear up for their business. So McKinsey said that, yeah, probably like we will sell almost 900,000 mobiles by 2000. So that's their predictions. That's actually a pretty impressive number, okay? Because during 1990s, we were not having that much amount of, or that many mobile phones, okay, on the ground. Right now, we have like every person or every second person has a mobile phone in his hand. So McKinsey's prediction is like somewhere around 900,000 by 2000. But what actually happened is, like in 2000, okay, AT&T, like they did sell 900,000, but they sold those 900,000 mobile pieces like in first 3 days of 2000. And in fact, what they actually achieved is like more than 109 million. So it is actually more than 120 times more. So if you actually like predict, okay, why this prediction has actually like gone wrong. It is not only wrong, but it is completely off the chart. Same like what we are actually like what we have seen. It is, the prediction is like completely wrong, but it's way wrong because we are seeing an exponential growth. So what has happened? Okay, why it is way wrong? So for example, in case of mobile, because of the cost. Okay, the cost has dropped sharply. You must have seen in your life as well. Okay, the quality of the mobile has actually like improved dramatically, and there is also this concept of leapfrogging. Okay, low-income countries, the countries who are not having telephone communications, they just like they don't actually go through this landline. Okay, they first move to landline, then actually go to mobile. They just like leapfrogged, and they just skip the step. And they went from technology, means without telephone technology, they just like go to mobile without going through this landline technology. So similar thing is actually like happening in green energy. So if you see the electric vehicles, okay, the trend in sales of electric vehicles, you see an exponential growth. I mean, as we see now, and it is going to have a great impact on the oil demand. Okay, and they are saying, okay, it is not going to happen like a decade after. It is going to happen very soon, in next 2 to 3 years. The ingress, or like because of the increase in sales of EV, it is going to have a very great impact on the oil demand, and it is going to be to the tune of like more than 2 million barrels per day, which is substantial because the recent drop in oil price, you must be knowing, it was like hovering around close to $100, and it dropped like close to like it even touched like close to like $20. Right now we are like in the range of $40-41, okay, per barrel. And this drop has actually happened because of this excess supply, and this excess supply will be like created, or the drop in demand will be actually like created because of this huge increase or exponential growth in electric vehicles. And if you see other clean energy like options like wind, so in 2000 they actually projected that the worldwide wind capacity will be almost like 30 gigawatt by 2010. Okay, but what has actually happened is like we exceeded that, okay, by 14.5 times, by 14.5 times. So again, an exponential growth, and the reason is because of the drop in cost. The drop in cost, okay, how much the dollar we have to like spend, or like to get 1 kilowatt hour energy of wind, it is actually like falling down year on year. The onshore wind cost is actually like falling down year on year, and is expected to continue to fall. And again for solar PV, so in 2002 they actually projected that, okay, it will be 1 gigawatt per year by 2010. But in reality, we are actually like talking about 17 times by 17 times. By 2015, we are actually talking about 50 times. So we are again talking about an exponential growth right now. Okay, in 2019 means we have more than like 627 gigawatts of solar PV installed, and it is going to be, it's not going to taper off, and we expect that again it is going to grow exponentially again. And that's actually because module price is actually like falling down year on year. So right now, like, okay, the current cost of okay, to produce or okay, the solar PV module is in the range of $0.2 per watt. And to produce electricity from solar PV, it used to be like a very high cost. 10 years when I started my career, okay, it used to be very high cost. But right now, if you calculate the levelized cost of electricity to generate from solar PV power plant, okay, if you are talking about scale of bigger power plants like 800 megawatt, 1 gigawatt power plants, it is like amazingly like cheap. Because I'm saying cheap means, for example, in India, the average power cost is like 3 to 5 rupees. Yeah, 3 to 5 rupees per kilowatt hour. If you want to buy 1 kilowatt hour of electricity in India, but solar power cost right now, it is in the lowest bid. The very recent lowest bid which we got in Abu Dhabi for an 1.5 gigawatt power plant of solar PV, it is like 1 rupee. Okay, so and if you want to generate if you want to generate coal power from a coal-based power plant in India, we have to spend almost like 3 rupees. Yeah, 3.05 rupees. So the solar PV cost has actually fallen down substantially, and it doesn't make any business sense right now to go and build a coal-based power plant, and then of course definitely not an oil and gas or oil-based power plant or diesel-based power plant. It is like very expensive. So it is making a very good business sense right now to go for solar PV. Yeah, and yeah, like okay, so we also like being flooded with a great amount of energy, and every hour, like okay, we get an energy need for 1 year, and countries like Germany is already like seeing most of the electricity generated from renewables. On December 15, they generated 81% of their electricity from renewables. On Jan 2018, they actually like generated 100% of the electricity from renewables. So it is like an amazing journey. So what has actually like driven this change? So it is not about oh yes, like we want to be green. It's not about that, okay, yes, okay, we want to reduce emissions. Of course, like they are like they are objectives, but the primary thing which has driven this transformation in clean energy is simply the cost economics of the renewable energy generation. Like it has become more and more attractive, and it doesn't make any sense right now to go and install a coal-based power plant, or it doesn't make any sense to install gas turbines. So that's why, like for example, the company GE, the famous company which is very famous for a lot of other things, but they have a very huge a division which generates gas turbine. And if you see their annual reports, every year they're actually like writing down their assets, or the value of their business is actually coming down, because nobody is actually like going and installing gas turbines, because it's becoming much more better to do solar PV, which is like the cheapest source of electricity generation. Okay, so here is a question. Simple question though. So which forms of energy are ultimately derived from solar energy? Any thoughts, responses? Okay, so most of us saying which forms of energy ultimately derived from solar. So if I ask a question, okay, instead of that, which form is not derived from solar energy? Not derived from solar energy. Which one you will say? not derived from solar energy, not derived. I can see Nathan. Okay, most of them saying D. Some of them saying D, in fact. Yeah. Okay. So whoever have said D or nuclear, okay, you can give a tap on your shoulder. Yeah, that's the right answer. Yeah. All other forms are like from solar. Okay. So the world is actually like moving towards a sustainable future, but where do we stand? Okay, where do we stand? So are we like, okay, moving in the right direction? So we talked about the carbon emissions are actually going, is growing up year on year. We are like talking about 415 ppm of CO2 emissions, okay, right now as we speak. So how the countries are compared among each other. So yeah, unfortunately, like, okay, right now I'm in a country which has the highest carbon footprint. If you see like China, like, okay, it's in the range of like 4 to 5 tons. In India, like, okay, we are like, okay, on an average, every per capita emission is like, okay, almost like 1 to 2 tons, 1.5 tons of CO2 per person. On an average, the world average is like close to like 4 tons. So we are, and because of that, like, okay, means just to like recap the emissions, because of the emissions, like, okay, we see the CO2 ppm has gone up, and we see this like the ice caps melting and the sea level are going up. And they came up this because every country is actually like emitting at a different rates. Some countries are more energy intensive or carbon intensive in nature, and some countries are not. So they segregated those countries like developing countries and developed countries. And those and developed countries like primarily were having higher energy intensity or high emission intensity per capita, and developing countries were having lower energy intensity or lower per capita emissions. And we saw these impacts, just to recap. So they came up with this mechanism to price the carbon. Okay, so why this is happening? Because we know that carbon emissions is ultimately like driving global warming, and consequently it is affecting the way we saw in terms of economic impact, which we saw. So they came up with this concept of pricing the environmental externalities. And it worked very well, in fact, to control the acid rain in US. And they had a similar way to like price the SOx emissions, and they had a huge success. Okay, so they also like try to price the carbon. In fact, it was actually part of the famous Kyoto Protocol agreement, and it created this first the international carbon market. It created the famous clean development mechanism, where the developing countries can take actions to reduce emissions and convert into carbon credits, and those credits can be like sold to the developed countries, and thereby like, okay, they will be able to meet their set targets to reduce emissions. So it's like an amazing concept. It was successful. And in 2015, they created an agreement. It is famously called as the Paris Agreement, and it was it happened in like in the UNFCCC COP21. They call it as Conference of Parties 21st meeting, and they said that okay, on an average, means the countries have to take actions to reduce the global warming temperature well below 2 degrees. Right now we are talking about like 0.74, 0.75 degrees. So we have to reduce below 2 degrees. A lot of parties agreed and signed, and it's quite a protocol. It was created before 2012, and they created this market, and they priced the carbon. But there were issues like in carbon pricing. Okay, issues when carbon pricing, because there is a very delicate balance between setting the targets and providing allocations. Means like how much the country can emit, or how much the country in turn to the companies, the more polluting companies, can emit. And it is very difficult to like predict financial slowdown. So when I was working in HSBC to set up this carbon trading desk in early 2008, we were like not able to like see what is actually coming. And the 2008 recessions created a drastic slowdown in economic activity, and because of that, the countries were having excess allowance, especially the EU, and because of that, the price of carbon fell down like drastically. It fell down like almost to zero. So it's a challenging subject, and created a lot of policy uncertainty. So pricing carbon like looks simple, straightforward, but it's a challenging situation. And also like it's not like very uniform. Okay, if you see the emission trading systems across the different parts of the world, the price of carbon actually like ranges from $1 to $131. So it's like completely like I would not say random, but it's having a huge range. And are we like pricing the carbon at the right level? Okay, is also a question. Okay, is it like sufficiently enough to drive the transition towards clean energy? If you price the carbon too high, then it will affect the economy. If you price the carbon too low, then companies like us, like oil and gas companies, we don't have an incentive to move towards a cleaner or a greener fuel. So that's actually like a challenge. But companies are slowly like trying to adopt, irrespective of whatever the market price is. The companies are like trying to set their own carbon price and value that as a part of their business model. Say, for example, BP, so they actually like talking about $40. So internally, they actually set a carbon price. ExxonMobil setting $60, Shell setting like $40. So every company is actually like trying to do it, but still it is not a very great successful model. Okay, to push the corporate companies towards like or to find the right balance in pricing the carbon. And still the world doesn't have a very commonly signed agreement, the Paris Agreement, which was signed in 2015. US recently pulled out. Trump said that, okay, no, like, okay, it is very unfair for US. He says that, okay, India and China also have to be accountable. So there is a lot of questions. Okay, who is actually like accountable for the problems which have created during this era of industrialization? So why this is happening? Because like we have this problem or issue, and they can be like famously expressed in a way in two concepts called as the tragedy of commons. Okay, and it is actually not only applicable to climate change. In fact, okay, if you're like studying environmental economics, probably like this could be one of the concepts probably you'll be studying. So what it actually like says is, and it was actually like, it came from a famous ecologist called Garrett Hardin. So what he says is the main difficulty in solving the environmental problem is the conflict between short-term interest and long-term welfare of the society. So what it actually means is, for example, if you have a very common grazing ground for the cattle, and we have a group of villages like using the common ground, okay, to raise cattle, okay. So everybody will like have their own interest or short-term interest that, okay, I want to raise more and more cattle so that I can make more and more money. But we have a single fixed common ground available. But normally, like as a country or as a person, I would like to have more and more cattle. So I buy more cattle, or like okay, produce more cattle, and I use the same ground. At the end of the day, what happens is you will run out of the common. Okay, we'll run out of the grass, and ultimately, like everyone will suffer. Okay, so climate change is like one such problem, and the same concept can be applied, okay, on other issues like overfishing. Okay, people try to make more and more money through fishing, and ultimately, like okay, it's not only that fishing company, and everybody actually like, gets affected. So it's actually the issue of tragedy of commons. The other more interesting concept is the tragedy of horizon. Okay, and it's more very much applicable to climate change, because climate change is not an issue which is going to happen next year, or it is not going to happen in next 5 years, or not even in next decade. It is we as business, like as an oil and gas company, or a company where I worked for a bank. Okay, we all have an horizon. Okay, what should be the return on investment which I have to look from the business? From a business perspective, all we see is like, okay, next year, how much money I'm going to make? Okay, this year, my profitability is so much. Next year, how much money I'm going to make? As a bank, I will also like see quarter and quarter performance. So we all have a very short-term focus on what is the result. But actually, climate change has a bigger horizon. Okay, it is going to have an impact maybe like next 2 decades or 3 decades. So we as executives and investors, we have the lowest view of horizon. Okay, means we are actually like in terms of influence to change the world from current fossil fuel based energy dependent world to a much more cleaner world. Executives and investors, okay, we have a very great degree of influence. Okay, we have a very high influence, but in terms of vision, probably like okay, the more I'm worried is quarter on quarter profit. Then comes like the politicians and developers. Okay, we have a moderate impact, but their horizon is like okay, maybe like at the range of like 5 to 10 years. Then comes society, the community. They don't have any say. Okay, they have a very less influence. They don't have a great influence. Okay, they don't have a very great influence how the world have to shift. Okay, or should we like put in solar PV plant, or should I put like an or close down a coal-based power plant? Okay, as a community, we can't actually go and do this because we have less influence. But our horizon is like okay, like in the range of like 10 to 30 years, because that's what means we live the current society. But the next generation, our children, okay, they don't have any say in what we are actually doing right now. They have the least influence, but they have the highest horizon. They will have the highest impact.
Sorry for the interruption, sir. Rangavashim here.
Yeah.
For the BCH 5 third year chemical engineering students, they have a class at 4:15, so they will be leaving now. So this is so we have the rest of students and faculties. Okay, because of class BCH 5 third year chemical engineering students will be leaving now. We will continue the talk. Yeah, thank you.
Okay, that's fine. Yeah. So the climate change is actually like an issue of or a tragedy of horizon. So because of that, the concept of pricing carbon, having a common pricing all across the world, it is not happening. So what's the next attractive solution? So this again like an analysis from IEA, International Energy Agency. So they have actually like projected means what is our CO2 emissions and what should be the CO2 emissions to limit the world's rise in temperature less than 2 degrees. So they developed scenarios. And to achieve that scenario, what are the different kind of technologies which we have to adopt? So So if you like follow the current policy, so probably we will hit more and above 40 tons, okay, per year. But if you want to what the limit to less than 2 degrees, so we have to actually like hit like in the range of 10 tons per year. So what are the different options which are available? So we have options like clean energy we discussed, but the most attractive option is the energy efficiency. Okay, energy efficiency is the most attractive option. So we will see like in a subsequent slide in like 2-3 minutes why it is. But the most attractive is energy efficiency, followed by renewables, followed by fuel switching. Means like you switch from coal to gas, nuclear, or carbon capture and utilization and storage. Okay, it's not only about carbon capture and storage. You capture the carbon, you utilize it, okay, either for enhanced oil recovery, or you produce something like you put it in a fertilizer plant, you produce urea out of it. Okay, so you go for CCS and other options. So energy efficiency is the most attractive solution. Yeah, because energy cost is actually one of the major costs. If you take any industry, especially like cement, paper, aluminum, petrochemicals, energy cost as a percentage of manufacturing cost is actually, it's one of the highest. And for oil and gas sector, it means energy is product. And if I save energy, then I can sell that as a product and I'll make more money. So there are a couple of tools like which you follow, and how we actually like ensure energy efficiency is being adopted. The first one is the tool which you follow is life cycle costing. So whenever actually we design a plant, we see like several factors, and those factors include the capital cost, the operating cost of the plant, the maintenance cost of the plant. Then finally, like after the life of the plant, I will dispose of. And so there'll be an associated cost with it. And finally, like the residual cost. Okay, I can sell the plant for salvage. Okay, it can be like salvaged for the scrap metal. Yeah. So that actually like gives total life cycle cost. So you might actually ask a question, okay, how this tool is going to open my eyes on energy efficiency. So there are like several costs involved. So what's the great deal about it? So if you simply see, a simple example could be like, if you simply see the life cycle impact of in normal bottled water, okay, which I'm drinking, which was the municipal tap water, which we used to drink 20-30 years before, means we only had this municipal tap water. Okay, our parents had a very great life, healthy life using municipal tap water, and right now, okay, it becomes a fancy. Everybody's actually like using bottled water. And if you see the level of environmental impact, this bottled water, 1.5 liter of bottled water, it is actually like 33 times more worse than a municipal tap water. Okay, that's energy intensive to produce it, manufacture it, transport it. And so when you do a life cycle assessment, it gives this kind of it throws this kind of an answer. It shows that whatever like you're using, you take it for granted, is actually 33 times more worse than which were actually like using it before. And the reasons could be like several reasons. One of the key reasons, okay, the big companies, Coke, Nestle, okay, they made a huge money. They made they created a huge company out of nothing. In fact, 10-20 years before, there is no bottled water market. And right now, if I remember correctly, it is more than $110 billion of bottled water market right now. And they created out of nothing. And one of the basic factor they actually sold to us is fear. Okay, they all said is like, if you see their advertisement, they all said is like, my water is pure, purest water, okay, clean water, freshest water. Okay. So by keep on saying pure water, what they what they sold to us is, okay, anything you drink apart from the bottled water is impure water. So they sold fear, and they created a market out of nothing, which is like more than $100 billion per year right now. But if you do a life cycle assessment, it will change that view. It is like 33 times more worse. But if you do this life cycle assessment from an energy efficiency perspective, so that's a more interesting part. So if you do a life cycle assessment for a pump, okay, take a simple pump, any pump which you will use for water pumping or any pump, okay, over a period of like 15 years, and if you break down their cost, how much money I put to buy the pump, how much money I'm spending on energy, how much money I'm spending on maintenance, you will see that the initial money which we have to spend is hardly nothing. Like it's just hardly like 2%, and most of the cost is the energy cost, followed by the maintenance cost. So, and if you do it the same thing for motors, if you do it same thing for any other energy consuming equipment, anything which you use in your day-to-day life. So, for example, the LED lights which we use, okay, the CFL lights you use, the air conditioning systems which you use, you will find a similar chart. Most of the energy cost, or most of the cost, is actually the energy cost. The capital cost is hardly nothing. It will be less than 5%. But still, we take the decision based on the capital cost. Like within the company, when I'm actually evaluating the tender, I still actually take the decision based on the initial cost. When you go to a supermarket to go and buy an LED lamp, means you actually evaluate them based on which is the cheapest LED, yeah, or the cheapest air conditioning system which is available, because because another concept that itself is another subject which is called as the time value of the money or the net present value, because we actually prefer, or we value the money right now which is on our hand rather than the money which will come to us in the future. So that's another subject. But so doing a life cycle assessment throws in completely a different picture. So people actually not only do it only for energy cost, maintenance cost, and initial cost. They go to an extent that apart from the energy consumed by the product, how much energy it is being consumed during the product manufacturing itself. How much energy is gone into the materials which is used for manufacturing the product, or even for the energy consumed during the raw materials during the mining process. They call it as actually true life cycle assessment or total life cycle assessment, and it will throw in completely a different view. Okay, and if you see a lot of these green building standards which are defining the green buildings in US and also in India, they use this concept of total life cycle assessment, and they compare and contrast. Okay, should I go for wood frame, steel frame, or aluminum frame? They do this complete assessment, and there are a lot of softwares available. I don't know, as a part of the curriculum we study now, softwares like available, or OpenLCA. There are some free softwares available which we use to do this. The other tool which we use on a day-to-day basis, the pinch technology. So probably you might be also studying as a part of your chemical engineering course. So the idea is in any process plant, you ensure minimum hot utility and cold utility. Means you ensure minimum fuel requirement and the minimum cooling water requirement. It's actually an interesting subject. I studied as a part of my master's though. So probably, I don't know, is it now part of our current curriculum, but it's a nice concept to optimize the energy consumption of the whole plant itself. It's again a huge subject by itself. It's a huge subject for the entire SEM. It cannot be covered in 2-3 slides, but I just want to give a quick snapshot on what we mean by this. So the idea is actually to reduce the fuel consumption in our plants. So how do you do that? So for example, so here is a simple example. So here is a reactor. and we are having a feed which is going at 80 degrees, and the reactor is at 200 degrees. So to feed, before feeding into the reactor, since the reaction actually takes place at 200 degrees, I have to like heat the feed, the feed flow. So I use steam to heat it, okay, and the reaction happens at 200 degrees. Then the product actually comes out. So I cannot actually use the product at 200 degrees. So I have to cool the product again with the cooling water. So in this case, okay, I use steam, the steam which is being produced from maybe a natural gas based boiler, and the cooling water like from a cooling tower. So there is like two utilities we are using. So the idea is actually to integrate it as much as possible so that my steam consumption is at the lower side and my cooling water requirement is on the lower side. So that the point at which we achieve the minimum possible is called the pinch point. So all we have to do is like put in an additional heat exchanger and recover heat in a way that, okay, I use the product to preheat the feed. So it looks like very simple, but in real life, in a petrochemical plant or in a refinery, you have like multiple heat exchangers. So it requires a software like to do it. Okay, heat exchanger network analysis. Okay, it's a good subject, and it's also an iterative solution. Means like it had to do it like multiple times till we achieve the minimum delta T in a way that we have optimum level of energy consumption or okay overall for the plant. And the idea is actually to achieve an optimum delta T, we call this optimum pinch, in a way that how we define this optimum pinch. Because if I actually like ensure maximum heat recovery, okay, if I like okay increase maximum heat recovery, then my capital cost will be the highest because I have to put lot of heat exchangers. Okay, lot of heat exchangers. So my capital cost will be like the highest. Whereas like, okay, so I had to find a minimum point, whereas like, okay, I find an optimum cost, whereas like I find a sweet spot between minimum energy cost and minimum capital cost. So these are the couple of tools I thought that like I will quickly introduce, the life cycle assessment and pinch. And I think like I was like overshot by several minutes, but we as chemical engineers, so what is actually expected is we are like in a very special department. We are like unlike other departments like mechanical, electrical, or other IT industries. We are like a very special type of engineers. We study all these kinds. Means we can actually be fit in all these type of engineering problems. We are like a type of engineers. We can actually talk process, mechanical, electrical, and in everything. So we as chemical engineers, I just want to show a couple of slides and conclude. We need to be like we need to be a facilitator. We need to be a motivator. We have to like be a catalyst within the company to involve everyone. And more importantly, like focus on a particular term called focus on innovation and not creativity. Okay, and if you do that, means it will take you to a different level within the company. You might actually think that, oh yeah, the innovation and creativity looks same. Yeah, okay, it's like how to differentiate innovation and creativity. Both are like okay, thinking outside the box. But there is a very subtle difference between innovation and creativity. Creativity is like, yeah, you come up with a new idea, but like if you want to be an effective engineer, you have to be like innovator, means like putting the idea into practice. And if you do this, means you'll be like completely like different, and it will take you to a different level. I hope like whatever like we have discussed is informative. With that, sorry, like I've taken like such a long time, but that will be my last slide. Thank you so much for listening to me. Thank you. I hope like this is useful and gave some ideas on what we are actually facing as an industry. Thank you.
Thank you, Mr. Saravanan. It was actually a fairly elaborate view on how you guys work on sustainability and so on. And as you may expect, we actually have a lot of questions for you. So you want to take a minute and possibly answer a few questions? Is that fine?
Yeah, like we can actually like take the questions though. Yeah.
Okay, so some of them actually came in the chat. Some of them came in the chat. Some of them actually I received it personally. So I'll start with a few, kind of simple questions. The first question that was actually asked by Dr. Naren. So we kind of know that based on the supply and demand of a certain oil, you have this variation in prices. So OPEC, the US, and other oil producing nations, they fix a price, correct? And then you have these taxes and so on. So what is, just wanting to look at what is the margin that, companies and governments have on a liter of gasoline versus how does it affect life cycle assessment? So if I say I produce oil at, say, 10 rupees, and I sell it at, let's say, 20 rupees, unfortunately I have to pay about 50% as tax. So do companies take that into account when they do their life cycle assessment or an economic analysis to say, is it worthwhile to keep producing oil or is it worthwhile to go into any other energy source? Say, for example, drilling, so on and so forth.
Yeah. So yes, like when we actually like evaluate the economical attractiveness of a new oil and gas reserve, yeah, we do also like, okay, we'll check once we actually like get the oil and we sell it as a market price of like say $40 or $50, and then ultimately like if it reaches the customer at a much more like higher price because the government actually like adds up taxes to it, yeah. As you rightly said, for example, in India, like, okay, most of the cost is actually the tax imposed by the central government and the state government. So then ultimately it goes to the end user. And if it is not very economical for the end user to consider that final end product, then because of the economical reasons which we have seen or discussed, for example, like the solar PV, the case of solar PV, it becomes like more attractive to go for solar PV rather than to put a coal-based power plant right now in India. Then in that case, it is not a very great an investment for me, because whatever the investment as an oil and gas company, which I'm right now actually doing to develop a new oil well, I would expect it to run for like next 20-30 years. And in the next 20-30 years, I will actually like calculate, okay, so much barrels of oils per day will be the yield. And on an average, I'll be like selling it at like, okay, say $35 for next 20-30 years. And if it is not making any sense, because the customer is not feeling it, or like, okay, it will not make any sense for him and he'll switch out on an EV, then it's a huge problem for us, right? So we will definitely do that. We are doing that assessment, and that's how we make the decision.
Okay. Another question actually from final year student by the name Akila. In general, it has been seen that female chemical engineers do not get a lot of opportunities in the process industry. They might do R&D, but they are not seen in the process industry. So her question is, how broad are these opportunities in the chemical industry, specifically for female students and female candidates?
I would actually like say that although like, okay, we have the feeling that chemical engineers are not playing a major role in industries, but in fact it is not the case, because within ENOC, for example, okay, within my team, like we have like around 4 or 5 people. and they are actually responsible for managing the sustainability performance of the entire ENOC group. Okay, we have different companies. We have petrochemicals, oil refinery, we have oil wells in Turkmenistan, Egypt, and other countries. So we are like a team of like 4 or 5 people, and I'm very proud to say that all of the 4 or 5 people are like chemical engineers. All of them are chemical engineers, and in fact, like two of them are like a woman, and they too are like chemical engineers. So I don't think like chemical engineers have to be like restricted only towards or they only get opportunity in R&D, but but actually I think like we have like huge amount of opportunities. In fact, like within ENOC, if you list down, maybe like an oil and gas company, means we mostly have chemical engineers, followed probably by mechanical, followed probably by electrical. That's how it will be.
No, but no, her question was like, so in India, we have this shift system, so you go through these 3 shifts, right? And by law itself, you are essentially saying that a lady, a chemical engineer, a woman, can only work in the general shift, which is 8 to 5. And sometimes what happens is the general shift is usually used only for maintenance purposes, while the production actually happens in the next 2 shifts. It will happen in the evening shift and the night shift. So the question that most of these chemical engineers who are interested in the process are saying, we are made to work in the, because of government laws and the general perception. So she was basically asking about that, and is there an opportunity, you know, in working in production and in the process?
So even like I would say UAE is like more conservative than India, comparatively conservative in terms of like opportunities for women. But things are likely slowly changing up. Like even within our refinery, within our people, there are women. They are actually like working on. Of course, as you rightly said, they are working on general shifts. Okay, they are working on general shifts, looking after production. They are like process engineers working in production. So the trend is actually like definitely changing. I would say, when you compare like 10, 15 years before, right now, there are more women engineers, chemical engineers on the field. And within ENOC, like when I was not only in ENOC, when I was even working in Ernst & Young, so we came up with a kind of an approach where if you have more gender equality, especially in this process intensive industries, then the actual productivity of the company actually goes up. Okay, means like in terms of productivity, in terms of money which we make. So we have did a study, and we came to a conclusion that the more we have gender equality within this industry, then more sustainable is the company, and that is being actually true. So within ENOC, for example, we have a target. Okay, so much should be our female employees. Okay, on so and so positions. So we have a target, and if you don't achieve a target, then it gets penalized and in our group level scorecard. So it's changing, and it will change. There is no other option, though. I'm not saying just for sake of saying, okay, to support female or women, but that's how the world is actually moving towards it. Okay.
Okay, thank you. So there is, I will start first with the simple questions, because actually the loaded questions comes in later. Saravanan, who is of 3rd year chemical engineering, he is basically asking, how about developing large-scale fuel cells and promoting hydrogen fuel usage?
Yeah, definitely. Like hydrogen is actually one of the option, but I haven't actually touched about hydrogen for a couple of reasons. One is the technology itself is relatively, it's not that matured when you compare with what is available on the ground, like solar PV, onshore wind, or even offshore wind. Solar, onshore, offshore is much more matured than hydrogen. The second issue is like, okay, how to generate hydrogen? Yeah, like, okay, from where you will get hydrogen? Yeah, hydrogen is definitely a cleaner fuel. So when you say cleaner fuel, okay, you burn hydrogen, what do you get? So you burn hydrogen, you get water vapor. Yeah. so it is like more cleaner. So that you will not get CO2. So it's cleaner. But from where you will get the hydrogen? Because that's the issue. So the issue is like, okay, so probably like you have to actually do reforming. So again, go back to natural gas, reform it, get hydrogen, or like, okay, you use renewable energy, like, okay, and to store the renewable energy, you do electrolysis, split the water, produce hydrogen, store it, and use it back again. So either like, okay, so you don't have like much option, or probably like if you do like a biogas, then they produce hydrogen out of it. So the actual source of hydrogen is not very like I would say economical compared to like solar and others. So that's the reason like, okay, hydrogen is not it's not like it's not picked up. But fuel cell is definitely like we are even actually trying. We're working with a company called, I don't know, Bloom Energy. It's a US based fuel cell company. We're trying like on a pilot basis and see like, okay, whether it will pick up. But it is definitely much more long-term solution than solar and wind.
Okay. Because, one of the things that usually happens, and just quickly segue to Dr. Rangabashyam's question, as you were talking about biofuels. So he says, he asks, in search of a sustainable solution in energy demand, will biofuels of different generations still be under exploration? So he is looking at, can you use biofuels to meet the current demand?
Absolutely. So that's a great question. And when I was in HSBC, like we also like worked on this, because the problem with the biofuels is whether it is actually like working in a way that when the world is actually like suffering in terms of supplying food for the people, you don't actually like take that food and convert into fuel. So we have this energy and food nexus there. The other thing is it the biofuel is really carbon neutral? So there's a couple of issues happening in biofuel. So there are like several generations of biofuel as correctly identified in the question. So we have Gen 1, Gen 2, Gen 3 biofuels. There are like biofuel, the Gen 1 biofuels, like fuel from corn in US. So is it like, okay, when you do a complete life cycle assessment, is it like really carbon neutral to produce biofuels? That's a big question. There are, I believe, like, okay, we're talking about Gen 3, Gen 4 biofuels, which generates biofuel from the cellulosic waste, okay, rather than from the actual food, which can be used to feed people. So there are like concepts like on that, but since it is not very well matured when we compared with the current options, other clean energy options available, it is not it's not actually like picking up as we like to do. Because, okay, I have not actually touched about the topic of cost economics of electric vehicles versus cost economics of driving a fossil fuel vehicle versus the cost economics of running a biofuel based vehicle. And if you do an analysis, running an electric vehicle becomes more attractive. So that's why like it is not picking up.
Okay. Okay, so now here comes the much more kind of a loaded question.
Yeah.
Given that now you are actually seeing a slow movement of the world's economy towards cleaner fuels, renewable fuels, how does that affect the outlook of oil companies?
Yeah. So
because you are not going to make that kind of a money that you are making now, because we are more oil dependent right now. So as you showed that the forecast is actually going down, so do oil companies make a shift?
Yeah. So like at least like if you see like at least all the international oil and gas companies, we call them as like IOCs. Okay, IOCs means Shell, BP, Total. Almost all of them has actually created created a plan whereby they either created a plan, means they created a department or made an investment either towards electric vehicles or like towards clean energy, most primarily like towards solar PV. So that's why like you have these companies called BP Solar, Total Solar, and they have also created companies where they are actually moving aggressively investing into electric vehicle infrastructure. So oil and gas sector is, I would not say yes, it is doomed over next 5 years, 10 years, but definitely the sector is going to have a very big hit like in next 30 years, 30 to 40 years. Definitely there'll be a shift for within oil and gas. The world will definitely move on from oil next 30, 40 years. Definitely, that is very sure. And oil and the companies are actually like recognizing it. That's why it's a very, probably like I should have added a slide, okay, how this BP, Shell, and Total, they have actually valued down their assets year on year. And in fact, like there is a nice example. There is a company called Statoil, a Dutch company. Just you can Google Statoil. It's a very famous Dutch Norwegian, company. So they were actually initially called as Statoil because they are primarily focused on oil and gas business. Now, very recently, like 2-3 years before, or a couple of years, they have actually renamed themselves as Equinor. Okay, they said, okay, no more, like we are not an oil and gas company. We are actually called as an energy company. Okay, Equinor means energy. So they have actually heavily invested on offshore wind. Okay, so they actually moved away or planning to move away from oil and gas. Even BP, like they have this slogan. They were called as British Petroleum. Like British Petroleum is BP. So now they are actually calling themselves as Beyond Petroleum. So it's the companies are aware, but when you see the maturity of national oil companies, means like we are a national oil company, like owned by it's a released government. So means our movement is like a little bit slower compared to IOCs like Shell and BP, where they are actually like driven by shareholders and stakeholders, like common shareholders. Anyone can buy BP share, right? So they have a say. Whereas like we are actually owned by the government. So our transition is like much slower compared to international oil and gas companies. But transition is happening, definitely.
Okay. Same person. This is actually Raghavendra from third year chemical, and who I know is doing a lot of research right now in his free time. We only have 4 hours of classes. He's doing a lot of research on solar PVs. So he's basically saying this, when you actually do an environmental assessment, impact assessment of solar PVs or solar cells, a couple of things usually show up is solar PVs have lead contamination. You use a lot of chemicals to make the solar PVs, right? There is a lot of land usage as far as solar PVs goes. So it actually goes against the grain of deforestation. It cannot be applied. You can do it in a desert, you can do it in Rajasthan, but you cannot do it in Coimbatore, for example. So some environmental impacts are still there. It is not as green as said to be. So his question was, if you are focusing on solar PVs, what are the steps that are taken?
Yes. So if you do a complete life cycle assessment, there were like a lot of concerns. Okay, not only about the energy consumption during the production stage of solar PV. Yeah, so you basically like you produce it from silicon crystalline, either monocrystalline and polycrystalline, and it is like energy intensive in nature. And again, then once after the life of the solar PV, it has to be disposed. How it will get disposed, whether it can be recycled, and then the land issue. Okay, you take away the land, probably like it can be used for production. So there are like these are like very valid questions, and these questions were also like previously asked. And I remember that I have seen a lot of papers, a very detailed paper. Talking about means what is the total life cycle assessment, impact assessment of solar PV, and I'm not able to remember the numbers, but again and again, if you compare the total life cycle impact of solar PV against other energy sources, including all these issues, and it was actually proven that solar PV has the least impact, even if you consider all these issues. So when I was in HSBC, we used to publish these research articles for our investors, okay, and advising them to invest in clean energy. So we compared against other fuel source, energy sources like coal, natural gas, oil, nuclear, solar, and wind. And it clearly came out that even if you consider everything, solar has the least impact. Yes, I would not say there is no impact, but definitely the least impact. But if you tell me, okay, can you like remember those numbers? I'm not able to remember, but I can help you out. Maybe we can offline for sharing those papers which I published as a part of HSBC.
Okay, so I think that was would have answered his question. I just had a couple of questions myself. So a lot of this discussion on carbon pricing, a lot of this discussion on renewable energy and so on is always market driven. It is, I mean, we have to face it, economics drives everything. I remember this because during the 1970s oil embargo crisis, this was after the Iran and oil embargo and so on. At that time, the cost of oil in the US was roughly about $2.50 per gallon. Right? During that time, a whole lot of energy companies, including those in the Middle East, actually were doing a lot of research on coal liquefaction. So, in fact, there is a plant in South Africa which does that. And during that time, a lot of research was also done on converting carbon dioxide into liquefied fuels.
Yes.
The moment the oil embargo actually ended and that crisis got over, the price of oil per gallon went down to less than one rupee. In fact, there was a time when the oil was actually priced at, I believe, $0.8 per gallon. It was that low. So they stopped all that research. And this is, I'm talking 1970s, 80s. The research was done, it was successful, it was never taken to a production level. Now, the same thing seems to be applying over here. We kind of respond to, crisis situations rather than long-term planning. So now we are paying about $80, I mean $40 per gallon, per barrel, somewhere close to. In India, I remember 4 years ago, the price of petrol was 55. Now it is 85. I mean, it's taxes and GST and all of that. But supposedly, your price of oil, because now you're looking at shale gas, you're looking at offshore drilling and so on. Supposedly, I get a lot of oil. The price will again go down. So how do you factor that into telling the investor, please invest on green fuels? Because we did that earlier and we stopped it.
So how do you factor it to? Sorry?
Into telling the investor that there is a need for green energy, because we tried doing that earlier, we stopped that research and it is now put in the back burner. How do you tell the investor, okay, you want to do this for the next 20 years? I'm looking at 30 years later. How do you tell that investor?
So that's where the issue or the concept we discussed, which is the tragedy of horizon. So because different people have different level of view on to what years they will see the future. So we as companies, like we are actually worried about more and more like a yearly profitability. Okay, for example, if you're investing, if you're buying the shares of Infosys, for example, means all you will be worried is like, okay, next year how much a profit the company will make and how much will be the increase in share price, right? If you see the just a minute. One minute. I just finished the class. Sorry. Okay. So if you see the CEO's, any CEO, okay, my company CEO's performance agreement, you will see that their performance agreement are actually like tagged to the yearly company profitability or share price. So this is like definitely an issue, because companies, bankers, even policy makers, okay, for example, the government of India, the policy which they're actually like, all they care is like next 5 years what they can actually achieve. They don't actually like see, oh, by 2035 what India had to be. Means although like they say they lay out a roadmap, but the incentives are like more towards what they can actually nudge over next 5 years. So this is actually an issue. But how it will be driven, ultimately, like, okay, anything, although like we talk about doing good, sustainability, ultimately within the sustainability pillar, I would say the most important pillar is like the economic pillar. And if you're able to like convince economically the shift is making very good sense for the company, then the companies will simply follow it. So we see an exponential growth in solar and wind. Okay, it's not because somebody want to do good, or it's not because the government is actually like having a mandatory target, so much renewable energy have to be. It's not because of that, because it makes pure economical sense. So when sustainability makes economic sense, then people will follow sustainability. Means like it becomes automatically become a mainstream business case. So I would actually like say the economic analysis, being strong in doing an economic analysis or building a case is a very key for engineering professionals like us. So when you go and talk to the CEO or management on you, when you present the case, or when you even actually do a project, okay, like as a part of your like final year project, okay, all have to be like tied to an economic angle. That's the most important angle. And if you make the correct pitch on that angle, then the rest will fall in place. That's my experience, like what I had in the companies.
Thank you very much. I know it is getting late for you as well. So students, if you have any questions, I've actually made a note of other questions, and we can email it to Mr. Saravanan later, and he can put his responses, because he also has other pressing issues. So thank you very much, sir, for responding to all our questions. I would now like to actually call on your batchmate, your friend, our Professor M. Saravanan, to present his vote of thanks. Saravanan, sir.
Wonderful.
Thank you, Dr. Gautam. So I am actually very glad to propose the vote of thanks for today's event, which is conducted under the aegis of Engineering Lecture Series. So first of all, I'll like to thank our respected and beloved Dean, Dr. K.S. Roger, for providing this opportunity on this platform, okay, for the interaction of the students with expert professionals from the industrial side. So I'm very indebted to our distinguished alumni and speaker for today's session, for readily accepting our invitation to deliver a talk in this lecture series. And I also thank him for his wonderful informative lecture. And he has an attribute of going into in-depth. So he has an attribute of say learning in depth rather than a peripheral learning. So I think he has shown in this exhaustive lecture, so covering around more than 2 hours of this session. So I'm just very thankful for accepting and delivering this lecture, and also as being a day off for him. So actually he's actually sacrificed his weekly day off for him. So I am also thank the other faculty members for in our school, but not least I thank the student friends for their participating in this lecture series. Not only participating and also actively involved in posing relevant questions to the lecture, to the speaker, and thereby utilizing this pandemic period for knowledge expansion. So I'll just take special mention for Dr. Rangabhashya, the coordinator of this lecture series, Dr. Gautam, Dr. P.R. Naren, as well as Dr. V. Alagesan for their support and cooperation in successfully conducting this event. And once again, thank you, one and all. And special thanks for my batchmate, classmate, and also my lab mate for accepting this invitation and delivering a very insightful as well as exhaustive lecture. Thank you, one and all.
Thank you,
Thank
Saravanan.
Thank you, Saravanan sir. Both Saravanans, I should say. Thank you very much. Taking your time off today, you had. I know it's one of those days. I think you have to go back to work tomorrow. So thank you very much from from all the faculty members of this department. Thank you. Thank you.
Thank you. Thank you very much.
Thank you. Pleasure is actually mine. Thank you. Thank you for this opportunity. The pleasure is actually mine. In fact, to have a nice, it's kind of a throwback. It also refreshes my memory as well and my thoughts as well. What we have to do for oil and gas sector. Thank you so much. Really appreciate this.
Thank you.
Thank you.